Alright, so in this problem, we're looking at how kinetic energy changes based on whether our mass or our speed change. So we're given in the problem that our initial kinetic energy is 150 joules. And if we're looking at how that's going to change with our mass or velocity, we need our kinetic energy formula. So we need that kinetic energy equals 1/2 mv squared. Because we're given that 150 joules in the problem statement, we can say that 150 equals 1/2 mv squared. So anytime we can group together a 1/2 mv squared, we can sub in that 150 and make our lives a whole lot easier to get that numerical answer. So for part A, it says, what if the mass is doubled and we're moving at the same speed? So we can say our new kinetic energy, K prime, is 1/2 times 2m times v squared, because our mass doubled here, so we're just multiplying by 2. To get that 1/2 mv squared together, we're just going to pull out a 2, and then we have 1/2 mv squared. So we can sub in our 150. 2 times 150 gives us 300 joules. So if our mass is doubled and our velocity stays the same, our kinetic energy doubles. So for part B, what if our mass stays the same but our speed doubles? Well, we're just going to say that our new kinetic energy is 1/2, our mass is staying the same, and our velocity is being doubled. But we need to remember, when we double our velocity, we're multiplying v by something, and then we're squaring that quantity. Okay, so we have our 2v in parentheses with our power outside. Okay, so if we're trying to get 1/2 mv squared here, we need to distribute this power first. So we have 1/2 m times 4v squared, right? Because we had to square that 2. So if we pull that 4 outside, we can get that 1/2 mv squared together. So we have 4 times our 150, which gives us 600 joules. So that's our new kinetic energy if our mass stays the same but our speed doubles. So you can see if our mass changes or our velocity changes, that changes our kinetic energy in different ways because of how they are in the formula. So for part C, our mass is halved and our speed is doubled. Alright, so for part C, we have our new kinetic energy equals 1/2 times half the mass, because our mass is halved, and our speed is doubled, so we're going to have 2v quantity squared. That gives us 1/2 times 1/2 m times 4v squared. So here we can pull out our 1/2 and our 4, and we have our 1/2 mv squared left. So now we can combine that 1/2 and that 4 to make it 2, and we still have our 1/2 mv squared. Remember, our 1/2 mv squared is still 150, so we have 2 times 150 gives us 300 joules again. Okay. Now for part D, we have the same mass with half the speed. So we have 1/2, same mass, and half the speed. So we just plug in the same mass and 1/2 times v inside our parentheses with that square outside. We have 1/2 m times 1/4 v squared. We pull out that 1/4. We get our 1/2 mv squared together. So we can see that that's 1/4 times our 150, which gives us 37.5 joules. Right, so that's much smaller than had we just half the mass. All right, so we have that 37.5. And finally, for part E, we have the mass is tripled and the speed is halved. So we say our new kinetic energy holds at 1/2. If our mass is tripled, that means we're multiplying by 3. And our speed is halved. So we have 1/2 times v with our square outside. So we have 1/2 times 3m times 1/4 v squared. So we can have a 3/4 outside if we combine, or if we multiply the 3 and the 1/4. And then we have a 1/2 mv squared left. 3/4 times 150, making that substitution, gives us 112.5 joules. So all we did was plug in what changed and looked for our original formula in order to plug in and find out how our kinetic energy changed.